Hello, welcome back. And today we're going to talk about subsets. So if set A is a subset of a set B, we use this notation. Okay? This means that every element in A is an element in B. Okay? So they should have the same elements. Maybe in a different order, but they should have the same elements. If we go ahead and use a different notation, this means it's not a subset. So you probably are seeing a little bit of a trend here. Ugh, set, not sent. Oh boy, gonna be one of those days today. Okay, so not a subset. Okay. The empty set, though, is a subset of every set. Okay, so that's the big thing you got to remember here, that the empty set is a subset of every single set. Let's go ahead and look at a couple of examples here. And I'm going to go ahead and do example 1. Okay, so I have two sets. I have A, and I have 1, 3, 4, 6, 9, and 11. I have set B that has the elements 1, 3, 5, 7. All right. And I want to know, is A a subset of B? Okay, so is every element from A included in B? In this case, it's not. So this is not a subset. Right? If we go ahead and look at part C for this one, I have X is such that X, all elements in X is a day of the week. Excuse my horrible handwriting today. All right. And set B, this is set A, set B is a list of the days of the week. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay? And I want to know, is A subset of B? And actually, yes, it is. Every day of the week is included in here. So A is a subset of B. Okay? So I want you to go ahead and look at example 2 and the rest of example 1. Give them a try, see if you kind of get the idea of what's going on. Again, I recommend pausing this video, going ahead and working through those. Okay? And we'll go ahead and meet up in just a minute or so. Okay, now that we have talked about subsets, I want to talk about something that's a proper subset. Okay, and a proper subset, if A is a proper subset of B, it just has this, there's no equal underneath of it. Okay, so if set A is a subset of set B and set A is not, and they're not equal, then they're not equal. Let me re-say that because it sounded really weird. Okay, if A is a proper subset of B, we go ahead and we write it like this. If A is a subset of set B, but not equal to, we of course write this. Okay. A proper subset, sometimes the sets are not the same. In fact, a lot of the times, that is what happens. Now, the empty set is a subset of every set. We talked about that earlier. It is also a proper subset of all sets and this is a big one, except itself. Okay, so the empty set is a subset of all sets. It is also a proper subset of all sets, except itself. Very interesting. Okay, so I want to look at example 3, part A, right, where I have a set A is equal to 2, 4, 6, 8. Set B is equal to 2, 4, 6, 8, 10. Okay, now obviously set A is not equal to set B. There's more elements in that. Okay, is set A a subset of B? Is every element from set A in B? That is true, it is a subset. Is it a proper subset? Okay, if we look at it again, A is a subset of B, and sets A and B are not equal. It is also a proper subset. So this one is both of those things. Okay, so it is a subset because every element from A is included in B. It is a proper subset because A is included in B and A and B are not equal. And I hope this really clarified this a little bit. And I know if you go ahead and look at example 4, there's all sorts of parts to it. The one I want to look at is part H, where I have the empty set and the empty set. Is it a subset? Absolutely. We already know that this is a subset. Is it a proper subset of itself? No. Okay, remember that's the exception. So go ahead and work through those. Take a few minutes to go ahead and do that. And if you are really confused still, please go ahead and reach out to me. I'm going to give a couple minutes before I go on to our last part of this. Let you get time to work through those. And then we'll go ahead and wrap up 2.2. All right, the rest of 2.2. All right, we want to look at distinct subsets. Okay, the number of distinct subsets with n elements is 2 to the n. Okay, so you can tell the number of distinct subsets by counting the elements and then writing it as an exponent to 2. Okay, so if I go ahead and I have 3 elements. Oh, my pen is giving out on me again. I don't know what's going on with the pen here, guys. So 3 elements. You're going to go ahead and have 2 to the 3rd power, which is 2 times 2 times 2. And that's going to give me 8. There we go. So 2 to the 3rd, which is 2 times 2 times 2, which is equal to 8. All right. If I want distinct proper subsets of n elements, I have 2 to the n minus 1. So again, if I have 3 elements, I have 2 to the 3rd minus 1, which is 8 minus 1, which is equal to 7. All right. What are the subsets of the empty set? Something for you to think about. Okay, how many subsets does this have? Well, it only has, does it have an element? It's empty, right? Remember, this is equal to this. Anything to the 0 power is 1. All right, so go ahead and work through some of the examples. This is the end of 2.2. It's a very short section. I'll meet you on the other side for 2.3 for Venn diagrams.